So hello friends, welcome back. And so we have another lead code problem called climbing stairs. So first of all, I will walk you through the problem statement and then we will go on to the approach, right? So you are climbing some stairs and you have to take n steps to reach to the top. And what you have option in your hand is either you can choose to climb one step at a time or two step at a time. In how many ways you can climb to the top, right? So for example, we have 2 and we have 3. So the answer for 2 is 2 and the answer for 3 is 3. I will explain how. And the constraint is also here. So yeah, let's see the interview style way. So the first of all thing which strikes your mind is that, okay, for n equal to 2, your answer was 2. And for n equal to 3, your answer was 3. So let's suppose if I have this stair, right? So it has only one step. See, what is in your hand is either you can have one step or two steps. So if it has, say it is a ground and you have only one step, one stair, right? So you have only one option, yet you will take only one step. So for n is equals to 1, you have only one option, right? Okay, if you have something like this, so you have first stair, second stair, and you have ground, then you will have this, either you can have this one step, or what you can do, you can straight away have a two step. So for n equal to 2, number of options you have is either you will take 1 or you will take straight forward 2. So you have two options. Okay, very fine. Now for, let's suppose for 3 also, let's take C. So if we have 3, which means ground, 1, 2 and 3. So what you will do, you will take 1. Now when I reach the 1, now my problem is reduced to 2 stairs, which was same as in this case. Okay, very fine. But what if I could also have steps too? So my problem is reduced to one staircase. It means that I can write it in a reverse way also, which means that here, as I showed you that from the here I reached the stage 1 or stage 2. So when I reached on the stage 1, so I have the problem left was of stage 2, right? Or I can reach to the stage 2, so I will have a problem left of stage 1, right? Which I have already found here. You can say which I will already found here, or I can again find it basically. But I know the answer, right? So what I will do is that, let me make it reverse. So instead of seeing from here, let us take from the end, which means that if I say in my local language that if I am on here, so what it means, either I would have arrived from the last position or from the last position. If I had arrived from the last position, so the rest of the sub problem will be solved, right? And if I have arrived from the last to last position, so the rest of the sub problem will be solved, which means that to arrive at the f of n, I need to arrive from either of f of n minus 1, which means I take one step, or from f of n minus 2. So now I need to find all the number of ways, right? So I need to find all number of ways. So to arrive at f of n, I will do a sum of f of n minus 1 and f of n minus 2. So f of n will be nothing but f of n minus 1 plus f of n minus 2. Now, straightforward, I will find this reconciliation in my interview and I will say, okay, sir. So as I can clearly say that it is a standard Fibonacci series, right? So, sir, what I will do is that I will use the recursion basically, and I will find the value of f of n, and my base case would be for one step I would have only one option, and for steps which are two, I will have two options, right? So if I want to ask, like if I want to answer this in the interview, I will have these two ways. But I can clearly see that, okay, if I have some f of n and I will have a function called to f of n minus 1 and f of n minus 2, then same for f of n minus 2, I will have a function called to f of n minus 2 and f of n minus 3, until where n minus some k it is more than 1, right? Okay, and it is same here, f of n minus 3, f of n minus 4. So as you can see that, okay, if I use this recursive method, so for every stage I have two options, and I am moving this up to last which means that how low it can go up till n. It means that up till n is not finished. So at every stage I will have like up the depth would be n, and at every depth I have two options. So it would go up to big O of 2 raised to the power n. It is the time complexity, and the space would be big O of n. Why n? Because it would be a stack. If you don't know, then the recursion works on the basis of stack. So the stack which would be made, it would be of this n depth, right? Okay, so I am pretty sure that one method is this, but here as you can see the constraints, then n is less than or equal to 45, which means that 2 raised to 45, it is nearly about 3 into 1e13, I guess, or around it, which is like very large, way very large. And I can also see that if I have this f of n minus 2, so I am again finding this value of f of n minus 2, right? So it is not good for you if you see. So what you can do is that you can save this value of f of n minus 2, and whenever I want this value of f of n minus 2, I will return it without solving this particular subproblem again. So if you don't know, then it is a standard way which is called as dp, right? So in dp basically we for recursion plus memoization, which means that I can either follow the recursive way and memorize my particular thing, or I can simply do iterative dp as well. So it is basically dp when you memorize something so that you don't pre-compute it again. Because see, एक बार अगर आपने कर दी गलती तो गलती क्यों दोहरा रहे हो? ऐसे ही अगर एक बार आपने सॉल्व कर दिया तो उसे फिर सॉल्व क्यों कर रहे हो, राइट? सो या मतलब it is unnecessary, or you can say irrelevant, to solve one thing again and again. So what I will do is that now how it will help me. So for every stage, I will find my answer for only one time. So my time will reduce to O of n rather than 2 raised to the power n, and my space, as I'm using stack again, so it will also be reduced to O of, it will also remain O of n. So it would be my reduced one. And if I should say, then yeah, it will work. But if my interview still says that, okay, Aryan, I want to make it more optimized, right? So if you can optimize it further, like in anything, space or time, anything if you want. So I will say, okay, sir, as I can clearly see that, let me write it again. So I can say that I can clearly see that if I write it in an iterative way, right? So what I can see that my dp of n, it is basically dp of n minus 1 plus dp of n minus 2, right? Because I said basically I have make this recursive function to the iterative function, right? So if I make my array, then for the base cases for n equal to 1, I know my answer is 1. For n equal to 2, my answer is 2. For n equal to 3, I will have these values of from the last two values. So I will write it as 3 here. For n equal to 4, I will have my answer for n equal to 4 from the last two values, which means this and this. So I will have my answer 5. Right. So I can clearly see that I don't need to store the whole DP array. It is a waste for me. I just only want the last two values, which are they basically this and this. And for further things, suppose I want for n equal to 5. So I only need the last values, which is 5 and 3. So rather than making this whole array, I will have two variables called first and second, or you can name it anything, right? So you will update these variables whenever you will move to some particular n, and with the help of this, you can find your answer in O of 1 space rather than using a O of n space. So finally, I reached to the point where I have O of 1 space use and I have O of n time. Yes. Now my interviewer, like although it is the extreme case, like usually you won't be asked to optimize it more further. It is like the you have reached the limit, right? But the interviewer, okay, my marker is not working. I don't know. So what happened? Okay, so the interview might again ask you that, okay, you want to optimize it more further. So although for you guys, I am leaving it here because see, I am pretty sure that interview might will not ask you, but you can still optimize this more further. I don't know, but everything is stopped. Uh, yeah. So what you can do is that, okay. So yeah, as I said that encoding overloaded. Okay, sorry. So sorry for this lag. But yeah, so I can say that you can optimize this in O of log n by using a matrix exponentiation, and yeah, but the program you write, it would be pretty large, and so I think that it would not be asked. But if still you want to optimize it more further and you want to have a great impression to your interviewer, then you can also study matrix exponentiation. But for this problem, I will leave it here and I will write O of 1 space and O of n time code. So the let's write first of all that to what point we have reached. We have reached O of 1 space and O of n time, right? Okay, so if I want to write first of all, then if my n is 1, then simply I need to return 1, right? If my n is 2, then I simply need to return 2, right? Else, if my n is something, then I will have two variables called first, which will be 1. I will have another variable, let me write it here only. I will have another variable called second, although you can name some short variable, but I will not. So now you will run your loop from 3 to where, to n, right? And yeah, so you can have another variable called answer, uh, right? So what you will do is that your answer would be nothing but first plus second, and then now you want to make your new first as second, right? And your second as answer. Now when you have reached like out of this loop, so your final answer is stored in your answer variable, so you will just return your answer. So I hope that it should work without any errors. So let's try to submit it and let's see. So yeah, so it was pretty easy problem. I will place it in the easy part of DP, and yeah, it's all for this video, and see you guys in the next video. Bye.